Hello everyone, welcome back to the channel. This is Abhinav. So in this video, we are going to discuss the problem A, B and C of Codeforces round 782, which was a division 2 round. So there was a 15-minute gap in the contest actually when the server was down, and that time my B solution was in queue. So I was thinking that the that the contest will be, I think, unrated or something like that. But after 15 minutes, the server is again back, and I think that contest should not be unrated because everything was fine, and 15 extra minutes was given. So if we talk about the difficulty of the problem A, B, and C, the problem A was not so easy. It was a tricky problem. You can say it was a problem of rating more than 800, because usually the rating of problem A is 800, but it is of more than 800. Fine. If we talk about the rating of problem B and C, we can say that they are of same difficulty. As you can see in the submissions also, there is not a very big gap. The submissions of B is 4,000 and C is 3,000. So yeah, and I can say that the problem B was even more difficult than problem C, and I should not have spent more time on B. If I have done C first, then maybe my rank will be better, because C was a easy one as compared to B, according to me. You can also comment your opinion in the comment section. Now we can move towards the editorials of ABC. So problem number A. Problem number A is a good one, as I told. It is based on observations. So what it is given is that that basically uh, team red won R times and team B won blue won B times. It is given that B is strictly less than R, means the number of times team red win is greater than the team B win. It is always. So what you have to do is you have to output the combination of basically in which particular match which team wins, such that the maximum number of teams in a row one is minimum. Means, for example, in this particular string there is R, then 2 times B, then 3 times R. So R is winning 3 times in a row. The maximum is 3 times in a row, which is maximum. So we have to minimize this maximum. Basically we have to minimize this maximum so that it is as small as possible. ये जो चीज है ना कि कितनी बार एक साथ लगातार एक टीम कितनी बार जीत रही है, this should be minimal possible, right? So obviously for that what we can do is that we can for every particular R we can put a B in between, so that we can break the chain of wins of R. We can break the chain of wins of R. So let's understand this in whiteboard. So for example, there are 7 R wins. Sorry, let me first set up. There are 7 R's, and for example, 1 B. There is a single B, or you can say start from 0. We have 0 B's. So the win of 0 is, I don't know that is 0 in constant or not, but we are just taking an example. So in that case, what we can do is that in all the matches from 1 to 7, R is winning. R, 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 R. Okay. So 2, yeah, there are 7 R's. If the value of, this is when value of B is 0. Now if the value of B is 1, and for example R is 7, in that case what can be, in that case it can be 3 3 R R, sorry, R R R R R. So we have to put this particular 1B in between these R's, so that the continuous, means the wins of R in a row should be minimized. So we have to put B here. अगर हम लोग B यहाँ put करेंगे for example, then there is a 5 continuous wins of R and 2 here, so answer will be 5. But if we are putting B in between, then it will be 4 and 3. Now in case of B is equal to 2 also, it will be, how many R's are there? R, 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 R. So we have to put in between. One is here, one B here, then another B here. So basically what we can do is that because we have, basically we have a array, and we have to do its partition. How many partition we can do? We can do B plus 1 partition. because when the value of b was 2, we are doing 3 partition, 1 2 3. When the value was 1, we are doing 2 partition. When the value was 0, there was only 1 partition. So for a particular number of r's, we are doing b plus 1 partition. Okay, so what we can do is that what should be size of each partition? How can we count the size of each partition? The size of each partition will be x is equal to r divided by b plus 1. But obviously it is not completely divided. There is a remainder. There is always a remainder. So we have to put these, we have to set these y values of r also. So we can put these y values of r in any one of the y columns. For example, what we can do is, for example, the value of r is, means there are 13 r's, for example. No, not 13. Let's take it like a good value so that I can explain. It is, let's take it like 15. Okay, take it 15. Or we can also take it 12, 14. Take it 14. Okay, take it 14. And the value of b is, for example, 3. So now obviously there should be 4 partitions. So what should be the size of one partition? It will be x is equal to 14 by 3, and which is 4. Sorry, x is equal to 15 by not 3. It is 15 by 4 because we have to divide by b plus 1. So it is 3. So there will be 4 partitions, each of size 3. There are 3 r's. And in these partitions, between them there is a b. But there are 2 r's remaining. You can see that the mod of is 2. There are 2 r's remaining. There are only 12 r's. So we can insert these 2 r's in any of the 2 partitions. One here, any one of the 2. And hence the answer is 4. This is basically what we have to do. So we have to first check that in how many partitions we have to increase the value, which is the value of 5, and how many r's should be in each partition. This was my. I hope you get it. Let's move towards the code part, that what I have done. Because implementing this logic is also a difficult task. Many of you are finding problem in implementation also, as I was getting. So yeah, it's taking time. Yeah, and it is accepted. So fine, it is accepted. So what I have done is that here I have found the value of x and y as we discussed. Then for then if there is y, means there is a you can say extras we have to put. So we have to put one extra r in y column. So in y separations, or you can say y containers, क्योंकि हमारे पास कितने, हमारे पास b plus 1 containers से. So in y partitions we have to put one more r. So we are going up to x plus 1. Otherwise we are going up to x. And here we are printing the b containers, and here one more because there are b plus 1 partitions now. So here are b partitions, and here are the another one partition. That's it. This is how I have done the solution of this. So I will provide the link to the particular solution in the description. Okay. So now what we can do is move towards the next one. Okay, problem number b. Yeah, it was a great problem, and obviously you can see that there was one wrong summation on pretest 1 also, and you can see this some 13 minutes gap. This was because of that server. Okay, so because there was a very minute mistake which I was doing in this, and because of that server I have done it 13 minutes late. Otherwise maybe my rank was good or something else. Okay, yeah. So what we have to do is that we are going with a binary string n. Okay, you can make k exactly k moves. So you have to do all the k moves. You cannot do k minus 1 or 0 moves. You have to do all the k moves. In one move, what you can do is you can select a bit, and you have to flip all the bits except that. You have to flip all the bits except that particular bit. This was the problem. And by doing this, you have to find a lexicographically largest string which we can get. Okay. So basically there are some observations. Now maybe you will ask that how you think about that, how you observe that part. So that is basically very difficult to tell, but I will try my best to tell how I got that part. Okay, but the thing is, try to observe that after that observation, how I am implementing that and how I got the exact idea, exact logic. Because there are number of observations. After that, we can get a particular idea. So first of all, let me check that if my summation is passed on in queue. It is in queue actually. Okay, so it will pass in some time, and I am a bit confident about that. So yeah, let's move towards the whiteboard to understand it more clearly. That what I have done. Yes. So this is so. First of all, one off. Okay, that after doing two moves, what we are getting. This is what I have got. For example, we have a string this. So in one move, what I can do is I can pick this one and the other will become like this. And the other I can pick this one, the other one like this. This is what. So there was what I observed. Here is the main logic, what I have observed. You have to, okay, let do it once again more clearly. Just try to observe. Okay, try to observe. Pause the video and try to observe what I have thought. Okay, it was 10010. First of all, I have taken this one as fixed and swapped the others. And the next one, I have taken this one as fixed and swapped the others. What is the comparison between those, relation between these two things? You can check. If you have observed, try to observe that we have taken this particular and this particular. So after two moves, only these two bits are reversed. One becomes 0 here and 0 becomes 1 here. Others are as it is. So after every two moves, what we can do is we can reverse the value of two bits. This is the power of two moves. We cannot do it in one move. If we can do that in one move, I can reverse the bit of one, the value of one bit. It is not possible. But yeah, after two moves, we can reverse the bits of two. I hope this is clear. Okay, this was the basic observation. I think that the major observation which one has to think. Okay, yeah. So fine. Now, after observing this, what we have to do? Now one thing. Okay. When we have even number of moves, then we can divide that moves into 2, 2, 2, 2, 2. And in every two move, what we can do is we can flip the value of 2 bits. Here we can flip the value of 2 bits. So we can easily flip the value of bits which are required, because we have to maximize the string lexicographically. So we obviously have to make the zeros to 1. So in the first two moves, we can take two zeros and convert it to 1, like that only. But if the value of k is odd, in that case there will be 2, 2, 2, 2, 2, and in last there is a 1 also. So what we can do with this 1 is that in this case we are converting 0 to 1 because we want lexicography smallest. In this case, what we do is we will use these two moves to convert all the ones to zeros. We will do the opposite operation, all the ones to zeros. Because for example, if we have converted all the ones to zeros, then by using this last one move, we can convert all the ones, not all the ones, this to this by fixing a particular bit. If we have fixed this one, then the answer will be this. So if k is even, we have to change all the zeros to 1 if possible, and if k is odd, we have to change all the 1 to zeros if possible. And how we can do is by taking two moves in a row, because by making two moves simultaneously or continuity, we can change 2 bits, reverse 2 bits, reverse the value of 2 bits. This was the actual law. So I want you to go after that. इसके बाद आप खुद सोचो अब कैसे implement कर सकते हैं. After that also I know that implementation is very difficult after this logic. Let me first of all explain you the code, that what I have done actually. Okay, then it will be easy for you to understand the exact thing what we have to do actually. Okay, is the code so it is accepted, it's okay. What I have done is, it is a very lengthy code, you can see, so that is why I am telling you that try to implement your old code. You can see my code. This is, I don't know how I have written this particular amount of code. You can see this is the length. I think that one of the most lengthiest code in my CP journey, and it is also successfully passed. So yeah, I will try to explain this code. So what I have done, first of all, I have counted the number of zeros and number of ones. Okay, but I don't think that it was required anymore. Yeah, it was not required actually. That I have done that because I was thinking something else. Then there was a array answer, which is basically outputting that how in a particular index, how many times we are choosing that index. We are doing operation on that particular index. Now for the first, if k is even, as I told you, there we are converting all the zeros to 1, and also we can take two moves at once. So we are also checking that on always even number of moves are there. If the number of moves are odd, then we have to take one move to make it even, because हमेशा दो दो मूव करके ये लोग दो बिट चेंज कर सकते हैं. अगर सोचो कि तीन मूव करके तीन बिट चेंज कर नहीं हो सकता है, चार मूव करके चार बिट्स. फॉर एग्जांपल, we have to only change three bits. There are only three zeros to change to one, but then also we have to make four moves. Maybe by doing that we are changing one to zero, but always we have to do the even number of moves, because if we are doing two moves we can reverse two bits. If we are doing four moves we can reverse four bits, but we cannot reverse three bits by doing three moves. And that is what I've done here also. Here just a single one more array was there, one more operation was there, which was just checking, which was just flipping the last operation, which I have told you that if the value of k is 1, then at last there will be the one more operation, in which what we are doing, we are flipping all the bits except 1, because k is odd. So I hope you get it. So this code is very tricky. Try to implement your own code. Maybe someone else has written a more uh, pretty code, but my one is very confusing, I know. So if you have a better code, you can comment it down also. You can tell me the logic. So now let us move towards the problem number C. So let us check that is it accepted. Yeah, it is also accepted. So now it is confirmed that I am going to be expert today. So देखिए कब तक बन जाते हैं. Fine. Okay, fine. So this is a very amazing problem. This is a very amazing problem based on greedy technique only and based on some observations. So what we have to do here is that we have some unconquered kingdoms. There we have locations of that. We have to conquer them basically, obviously. So what we can do is we can make two actions. In the first action, what I can do is that I can change the location of my capital. I can shift from C1 to C2. Another what I can do is I can conquer a kingdom. Okay, so I can conquer a kingdom by doing with the cost of b into c1 minus c2, because of the relative distance between the kingdom and your kingdom. Right? So this is what we can. So let's understand the logic. Okay, very pretty logic is behind this particular problem. For example, we have this six kingdoms, six unconquered kingdoms. We are in this particular location 0. We have x1, we have x2, we have x3, we have x4, we have x5, we have x. This is what we have. Okay. Now, what we can do is that we for example, there's a type of moves and b type of moves. A is basically to move your particular uh, capital, and B is basically to conquer a particular kingdom. Let's take it like that. Okay. So, for example, you are here currently. So, for example, you are doing 0 A types of move and all the B type of move. So, you are not moving your capital anywhere else. You are just doing attacking this one, attacking this one, attacking this one, attacking this one, then this, then. So the first attack requires x1 into b cost, second requires x2 into b, then x3 into b, up to xn x6 into b. The cost required will be x1 plus x2 plus x3 plus x4. It is a bit of maths question actually, equation based question. Fine. Now, for example, after conquering first, you are moving to the first location and then conquering the other ones by the first location itself. So to move to the first location, the amount required is x1 into a. Okay, and to conquer this particular location, the amount required is x1 into b. And for all the others, the amount required will be x2 minus x1 into b plus x3 minus x1 into b. Sorry, into b. Okay, plus up to x6 minus x1 into b. Why x1 minus, and why I'm doing x1 again? Here I have basically done x3 minus 0 because we are at 0, but now we are at x1. We have come to x1. So this. For example, if we have now at x2, then how many are required? Then basically it is required x1b to conquer the first kingdom, obviously, to conquer the first one. Then x1a to reach there. Then x2 minus x1b to conquer that particular kingdom. Then x2 minus x1a to reach there. Means this is conquer the first kingdom, this is move to the first kingdom. Then this is conquer the second kingdom, this is move to the second kingdom. And after that we are not moving, we are just conquering the other kingdom. So for that it is required x3 minus x2b plus x4 minus x2b plus x5 minus x2b, like this we are continuing. Then we can move to the third kingdom, then we can move to the fourth kingdom, like that. We have to check for all the conditions, but not in a brute force manner. We have to find the optimized way. We have to find the optimized way. Okay, so what can we do? Tell me, what can we do? So you can see that in here what we are doing was, here when we were moving up to the kingdom 2, well, how many a was required? It was like x1a plus x2 minus x1a. So if we solve it, it will become basically x2 into a, because this x1 will cancel by this x1. So to reach a particular kingdom, to reach the kingdom second, the only amount required is x2a. To reach kingdom 3, the amount required is x3a. To reach kingdom 4, amount required is x4a. Fine. And also here you can evaluate these two conditions also. And to conquer that particular two kingdoms, the amount required is, we can cancel the x1 to this x1, only x2b is required plus x2b. So if we are conquering the first two kingdoms and we are moving there, amount required is x2a plus x2b basically. And if we are conquering all the other kingdoms without moving, so it is like x3 minus x2b plus x4 minus x2b plus x5 minus plus x6 minus. So it's basically x3 plus x4 plus x5 plus x6 into b minus x2 into 4, because they are x2 into 4b. This was the equation. So I want you to basically do it on your pen and paper. You will understand. Okay. So now we can obviously, for all the values of moves, if we are moving to first, if we are not moving to any kingdom, then also we can calculate. If we are moving to first, we can calculate. Let's move towards the code part to understand it more clearly, what I have done. Okay. So this is accepted. My summation accepted, and it's cool. So in the last, I will also check my rank and the rating change, so that I can check that yes, I am reaching expert or not. So if the value of n is 1, then obviously we have to just conquer a single kingdom. So we have just input output the value of b into b0 when n is equal to 1. Okay. Now when it is not, then here I have calculated prefix. It is basically the prefix array, prefix sum array from back, suffix sum array basically. Okay. So in, because as I told you now that here let me tell you that here when we are moving up to the kingdom second, then for all other kingdoms the formula is this. So we have to calculate the sum of, okay, we have to calculate the sum of. So for that I am using the suffix, so that I have not have to calculate the sum every time. Now if I is equal to 0 means we are not conquering any kingdom, we are not moving to any kingdom. Answer will be simply b into wi. What is wi? Wi basically sum of all the kingdoms. When we are reaching to the kingdom number I, so what we are adding is, we are adding a into v, because as you know that when we were reaching kingdom number second, when we are reaching kingdom number second, so how many required is x2 into a. So because it is 0 bias, x2 in x1 x2, so if we are reaching this second one, then how many these operations are required, what is the cost, it is x1 into a. Okay. So if we are moving up to the ith kingdom, then the cost required is a into vi minus 1. And how many b cost is required, it is basically vi means the sum of all the kingdoms after that minus vi minus 1 and minus I minus 1. That was the formula which I have derived, and then I am finding the minimum, and then print the minimum. This is what I have done. So yeah, this was also maybe a confusing one, but I have tried my best to explain. If you find doubt, you can just join the Telegram and ask me. Okay. So let me check my rank and my standings. And there is a message also, so I will check the message after the video. And today one person also messaged me in between of the contest, just that congratulations for the expert. No, I was like, oh, thanks, because I always afraid about that maybe the system test, maybe my code will be you can say failed, because sometimes it happens when I was suffering for specialist. Many time it happened that I have done good in contest, and after that in system testing or my code was hacked. So that was happened. So it was plus 35 today. My rank is average rank. It is okay. Swapnil sir has done great today. Yeah. So yeah, I was also trying the problem of B. Okay, the answer has also done this. Okay, fine. So yeah, so me so I check my rating. I 19 was required and it is plus 35. So yeah, finally I will be expert today. Yeah, I will be expert today. Okay.